Hi, my name is Josep Grau-Bove, and in this short video, I'm going to describe how the impact tool works. The impact tool is an online app that helps you calculate indoor pollutant concentrations. It was developed thanks to the research of colleagues in the Institute for Sustainable Heritage and the Norwegian Institute for Air Research. The app is quite simple, but it does have a lot of options. And in this video, I'll show the main options to be able to run some calculations and predictions. It has two main tabs, natural ventilation and mechanical ventilation. Let's have a look at natural ventilation first, which is the most straightforward one. First, you're presented with a box where you need to define a series of options that describe your environment of interest. The first one that we are presented with is a choice of pollutant, ozone, NO2, and SO2. These pollutants behave in a slightly different ways when they interact with surfaces. Then we have to define an air exchange rate that expresses how well ventilated our space is. A very low air exchange rate means that it's a very airtight space. A very high value would mean that it's a well-ventilated space. We need an operation temperature and relative humidity, which have an effect on how efficiently pollutants deposit on surfaces. And finally, we have to select what materials is our environment made of. This app is useful to simulate indoor concentrations in any type of enclosure. So you could consider a box, a display case, a single room, or a whole building if you want. The simulations or the predictions are going to be more accurate if your space resembles a large box with some openings. This is exactly the kind of thing that it predicts. Large boxes with some openings that are well mixed and where that can be well represented with a single concentration value. They don't have gradients. Let's see what these options do a little bit. The main output of the app is presented in this green square. This is the indoor-outdoor ratio. So the indoor-outdoor ratio tells you the relationship between the concentration of a pollutant indoors and a concentration of the same pollutant outdoors. In this case, an indoor-outdoor ratio of 41 indicates that we have 41% of the concentration that we would find outdoors. Therefore, you can run these calculations without having an exact knowledge of the concentration outdoors. But if you do have it, for example, because you have undertaken your own measurements, or you can obtain values from a public authority that measures pollution in your city, then you can just multiply this value by the indoor-outdoor ratio, and you will obtain an estimation of the indoor concentration. Naturally, the higher the air exchange rate, the higher the pollution indoors. So if we increase this by 10, you will see that there's a moderate increase in indoor-outdoor ratio. You know, might be surprised by this, but the reason that the indoor-outdoor ratio doesn't increase much with the air exchange rate in this case, it's because what's dominating the process is the position on the materials indoors. And that happens because I have added a lot of materials in this list on the right. So another important input is the number of materials that we adjust here. Right now, I'm considering two surfaces covered in plaster with an area of 1,000 square meters. So that's a lot. We can reduce this a little bit and make it more reasonable. And we should be careful to ensure that this combination of materials and the volume of the room represent faithfully what we are studying. Within the materials drop-down menu, there's a wide variety of materials, so you can describe anything from rooms to galleries and so on. You can select even paintings if you want. You have glass if you want to describe a display case. And as we add materials and modify them, we'll see this value changing. So for example, now you can see glass has a lot less capacity to attract pollutants than other materials, such as, for example, plaster, let's say a gypsum wallboard. I'm going to add another material just for the demonstration and give it a small area. And let's say this is going to be a painting. Once we have selected all this value, we have our estimation of indoor-outdoor ratio that we can use to aid decision-making or to compare it with measurements and so on. If we want to know more, we just have to scroll down and there are a series of other options that we can look at. Let's look at first at this table. There's a lot of detail in this table. I'm not going to stop now at the definition of each of them. I'll just say that these values V, T, Vs, and Vd, they refer to different deposition velocities. These values define how fast a pollutant gets into surfaces. If you want to know what they mean, they are described in a little bit more detail in the publications associated with this app. And then we are presented also with a percentage of deposition to different types of surfaces. In here, we can see that most of the pollutants in this environment end up in the plaster, and only a small fraction ends up on our paintings. Another plot that we can look at is the concentration through time. So what would happen in this environment if we start with a totally clean environment and we let it evolve? So you will see that the indoor-outdoor ratio is going to become stable after about 20 hours. This prediction changes dynamically depending on the values that we put in the input. Another plot that we can check is the relationship between the air exchange rate and the indoor-outdoor ratio. That's particularly important if we were not very sure of our air exchange rate, either because our measurements are imprecise or because we don't have a measurement at all, and we have taken this value from a table of typical values for a naturally ventilated room, for example, or from a publication on display cases, or from the specifications of our display case. In this case, you can see that it doesn't really matter if we vary a little bit our air exchange rate around the value that we have provided. The indoor-outdoor ratio, it's not going to change a lot. That might be surprising, but the cause, it's not difficult to understand. The reason is that we're showing indoor-outdoor ratio at equilibrium, meaning that it could take a very long time to get into this value if we have a very tightly sealed display case, for example, or it could be reached immediately if we have a very well ventilated display case, but we are always going to reach this value eventually. So what we are worried about is our average conditions inside. Sometimes the air exchange rate doesn't matter as much as the position on the surfaces. Finally, let's have a quick look at the mechanical ventilation tab. In this tab, we have many more options. In order to produce good estimations with this tab, we really need to have a good knowledge of how our mechanical ventilation system operates. There are several parameters that we need. It's not sufficient anymore to simply know the overall ventilation rate or air exchange rate. What we need to know now is all the fluxes that are represented by these arrows here. So we need to know, firstly, what's the proportion of fresh air that we introduce into the environment. Many mechanical ventilation systems work through a recirculation that filters the air. This gray block here represents the filter. And every time we do this recirculation, we have the option of introducing some fresh air that it's also filtered. So we need to know how much fresh air is introduced and how much is recirculated. We need to know what's the pollutant removal efficiency of our filter, and this is normally given by the manufacturer of filters, and it's an efficiency that it's gradually lost through time, so you need to be aware of this as well. It could be, if we don't have a filter, we can set this as 0 and it works anyway. Infiltration flow accounts for all the uncontrolled flows that are not directly by design or that are through openings in the building envelope, that may not be mechanical. So this could be 0 as well, if you will. And then the total air intake is all the air that it's coming in. It's interesting to play with all these options. The purpose of this app, it's not only to provide estimations that are accurate. It can do this if you have good input values, but it's also very good at helping you see what parameters matter the most in your space. So even if you don't have an exact value for some of these, it's useful to play and modify and see whether they alter the final concentration inside a lot or not. As before, you need temperature and relative humidity, and you can add, as before, as many materials as you want, defining your room, display case, or box in as much detail as you can. You can see that if we add many materials, the indoor outdoor ratio, of course, reduces to 0 because we have a lot of surface to deposit. The problem is how to fit 4,000 square meters inside a 300 cubic meter room. So we need to ensure that this is realistic. And then the plots that we're given afterwards are exactly the same. The calculated deposition and the dynamic plots of air exchange rate and indoor outdoor ratio. That's the app in a nutshell. Thank you very much for using it. Let me know how it goes.